Hi, guys. A little bit about me and my co-presenter before we get on with the talk. I'm Anshum Gupta for all of you who haven't met me yet at the conference. I'm a Lucidworks committer and a PMC member, being associated with the community for quite a bit now. I work with the search team at IBM Watson, working on the open source stuff most of my time. And my co-presenter, she's a big-time Lucidworks supporter, pretty much an NLP person, works at IBM Watson along with me, and obviously is interested in search and related stuff. So to get the agenda going, today we're going to talk about hierarchical data and what that data really means and how you want to see that data, followed by how you're going to use that data to index it into Solr. And then what are the different ways and what kind of queries can you actually perform on deeply nested data. And we're going to wrap up with, if you wanted to facet on this kind of data, which is deeply nested, how are you going to go about it, and what are the options available to you out of the box? So talking about hierarchical documents, what's the need for nested data? Data used to be pretty flat until recently. You had flat documents, you had some fields, and you wanted to search on those. Not anymore. If you look at email threads, you look at social media comments, you look at tweets, which have replies, and they have replies to them. You can map all of that by using a pointer and edge or something, forming some sort of a graph, or you could just have just deeply nested data in terms of especially comments and replies, because you want to retain context from the main thread going forward and not just the relationship. So while until recently you could work with nested data, so to say, by flattening it out, by just getting everything back into, normalizing it into a flat-looking document, it doesn't really work too well right now. If you really look at that example, which is pretty much how, from the data set that we're going to use for the rest of the talk, this is about blog posts with comments and replies and a bit of sentiment analysis going in for the post itself, the comments, and the replies. So if you really wanted to get answers to a question like get all positive comments to post about Donald Trump or that mentioned the keyword Trump, let's say you had all of this data flattened out. What are you going to do with that? You're pretty much talking about having a comments field and a sentiment field, which is a multi-valued field, which has all the comments related to this one post going in all together. What you're going to finally lose out is there's going to be one comment, let's say, which has multiple sentiments to it associated with different parts of the same comment. As soon as you flatten that data out, you're losing the context of the association of the keyword that you're talking about and the sentiment that you're talking about. So what you really want to do is you want to keep the context intact without losing any of that information. So now that's a little different way to visualize it, which is you've got a different level of nesting within the main parent document. So you've got the main post at the top, you've got a title, author, date, body, and then you've got comments inside that with some sentiment to go along. Now, if you wanted to get answers to the same question, which is positive comments to post about Trump, well, I'm not talking about whether that's a possibility in terms of the data itself, but out of Solr, yes, if there was such data, you would get back some results. So let's go on to looking at how this data looks like. And one thing I'd like to mention here is all of this data, all of these examples are on GitHub. So we're going to share a link to all of that. You wouldn't need to write down query syntax or other stuff that's on the slides. The slides are going to be shared right after the talk, and so would be the code and queries and the sample data set. So if you look at the data set here, you've got posts followed by an author for the post. You've got text, and then you've got a keyword section in there, which by itself is a separate document, right? So every keyword set is a document by itself, which is nothing but a combination of sentiment and text, right? And the post itself contains comments. The structure of the comment itself is exactly similar to post, just that comments now have replies underneath. The rest of the data pretty much is the same. So indexing nested documents. You've got a bunch of nested data. You want to get it into Solr. What are the different ways for you to get this data in? As trivial as that may sound, it's not that straightforward. One of the ways to get your data into Solr is using nested XML. So you just use annotations. We're going to talk a little more about it in the slides that are coming next. But you can use nested XML. You can use Solr's native JSON format, or you can use regular JSON, native JSON, right? So non-Solr format JSON. So if you look at XMLs, if you look at the format there, you've got the doc tags, and then you can nest them using more doc tags, and you can push this data into Solr, and this would get indexed. One thing to note here, though, is if there was any pre-processing that was required, that would be your responsibility here. So you'd have to change the XML to add a metadata field that you needed, or if you wanted to, let's say, flatten out things into field names into fully qualified field names, right? So you've got the main root doc that has a field called X, and then you've got fields inside that's called Y. You really want to call that field x.y and probably not just y. And converting regular field names into fully qualified field names would be your responsibility as an end user. So that's how you can get XML into Solr, just pushing it. The second way in is you can use Solr's native JSON format. What that requires you to do is, again, pre-process outside. Also, annotate every child document with a child documents tag that's highlighted there in red. So that's how you send in nested data into Solr using Solr's native JSON format. Again, it's the same thing. You have to pre-process field names to be converted into fully qualified field names. Like here, if you really wanted text to be comments.txt, you really have to rename that in your JSON outside before you even send it to Solr. Now, this is the most recent addition. The JSON document endpoint has been in Solr for a bit now. It's still relatively new, but it did not support nested data until pretty much recently, I think a couple of months ago. And what this endpoint lets you do is it lets you send in regular JSON into Solr without having to pre-process any of this. What it also gives you is the ability to go ahead and map fields. So you could say /a/b is going to be called a field, is going to be called foo, so that you can index this field as foo instead of this being indexed as a.b in case of fully qualified field name or something else. So you've got that ability to map field names. You also have the ability to specify where to split your root document. So you go out and say /post/replies or /post/comments is going to be a point I want to split at. And what that means is instead of that part being treated as just a multi-valued field, it's going to be now split into child documents, retaining the context, right? So you can do all of that, and you don't need to pre-process a ton of data outside of Solr. One thing to note here, though, is all of your documents need to contain a unique identifier, right? Which is a Solr prerequisite. A lot of you might have tried indexing data, and that works even without an ID right now, because the default update processor that comes with Solr out of the box automatically adds a unique identifier to Solr. Well, there's a problem there, which is the update request processors do not handle child documents at this point in time. What that means is stuff like auto addition of a unique identifier is something that you would have to do, because Solr is not going to be handling that for your child documents. It would still add a unique identifier for your parent document, but wouldn't do that for your child documents. So I'd suggest you just do it outside of it. At IBM, what we did was we actually changed the code. We updated the update request processor, at least for the unique identifier, to go ahead and explicitly add a unique ID for child documents as well as the root documents. There's been conversation in the community about we want to do something about it. This was brought up by Alexander, and I mentioned that we'd already taken care of it at IBM. The reason why we didn't contribute that back was because I wasn't sure if we wanted to go ahead and treat every independent update request processor separately and go on a case-by-case basis or just change the architecture completely to have all update request processors run for child documents, which may not be desirable a lot of times. So you really want to change that so that it's configurable. That change is not in. I don't even think there's a Jira right now, but that's on my wish list. So yeah. So yeah, right now the workaround for that would be anything that an update request processor is expected to do to your parent documents and you want the same behavior for your child documents, you should be doing all of that in your code outside of Solr. Or write code or update for Couch Solr for now, or probably put out a patch and just change it. And so now we already know how to index data into Solr, deeply nested data. Now, what if you wanted to reindex, a bunch of stuff? Specifically speaking, if you had a child document that you wanted to go ahead and say, oh, you know what, I forgot this metadata field that should have been added to a child document or all child documents, and I now need to go back and add this. Well, the way Lucene works and even how Solr works, is it indexes the entire parent-child block as a single block, right? So it means you can't go ahead and just reindex your child document. Forget about an atomic update for just a field. You can't even completely update a child document. You would have to actually rewrite the entire document, which basically means deletion of the entire block and rewriting the entire block. So if you forget something, it pretty much means reindexing that document. If you forget adding a metadata field, that pretty much means reindexing your entire data set. So do your homework, figure out what fields you want before you go ahead, especially if you have a large data set. You don't want to be reindexing it every now and then. And having said that, I'd say store things in Solr for the purpose of reindexing if either it's too expensive to just reconstruct that data from your original backend data source, or if this data is streaming and you just don't have access to this data anymore. So yeah, we just figured out how to send in data, and we also figured out how to reindex data and why would you need to reindex the entire block so far. Now let's move on to asking some interesting questions. We know how to get data in. Now if we want to really ask questions, that's the interesting part. So the easy question first, right? So text : trump, that's the regular Lucene or Solr syntax. You can go ahead, ask this question, and it works exactly as expected. One thing to note here, though, is you've got responses from everywhere, right? So if there's a field called text in every document, it's going to come back with every document, which basically means every child document in Solr is going to be treated as a separate document. So if you have a field that occurs multiple times in a parent document as part of child documents, all of that would come back as separate results. It wouldn't be restricted to just one parent document. So what you really want to do there is you want to add a metadata field for specifying your path. What we did, that's what we used to solve this problem. We use a field called path that has a prefix of the depth of the document itself, followed by the fully qualified name of the field. We're going to get there as to why you would need this and why you need the number 2 and why the fully qualified field name, and why can't this go into something else. But that query right there basically restricts you to comments or replies that mention the term trump. So you don't want root posts. You just want comments and replies that mention this term. And that helps you get your answers back. So yeah, that's what I just said. Let's move on. So now what if you wanted to return similar types from different levels? So which basically means you want keywords, right? Now keywords, as if you remember the structure, right? It's right there. Keywords is a part of comments, replies, the post itself. All of them contain keywords. Now what you're interested now in is, I just want all keywords that are Hillary, and I'm not bothered about whether the keyword occurs in a post or a comment or a reply. Now that's where that path name creation comes in handy. You can use a prefix query for that and say, OK, I want all keywords, and this is the text that I want. And that lets you go across different depths to get your responses back. So for the more interesting part, I'm going to hand it over to Alisa. Yeah.
All right, thank you, Anshum.
Yeah.
You will see him back at the last slide. So, yeah, we just saw Solr's capabilities of querying on data that is actually nested, but what we saw so far is that the condition on the documents that we are searching for and the documents that are returned, they're actually the same document. As you see in the example, we're querying for a text which has value Hillary, and we are returning the document where this text was encountered. So it's, although the documents come from different levels, like from third level, from second, they're still, it's kind of like a flat query like regular type. But what if we are interested in something, well, let's, because we have hierarchical data, what if we're interested, for example, find comments that had negative sentiments toward Hillary, and you see that here we have the condition on the search, which is written in green, and in the green box is on the level 3. And what we want to return the comments, the parent document to this comment, to that to those keywords. Solr gives us this possibility since I guess versions like 4.5 or something, so it's been around for quite a while. And let's consider this question. Find all comments whose keywords detected positive sentiment towards Hillary. So yeah, as in the query part, you see that there is main query, which is just express, right, what we're, the condition that we have. And in the orange part, in those brackets, we see that this is the block joined parent query. This is the block joined parent part, which specifies the parent of the documents that we are looking for and the type of this parent. And as a result, what is returned, we see that there are only the comments which has like text, field text and those there, but they don't actually contain keywords, because keywords is a separate document, and we've been querying for the parent document, for documents, for comments. That's what we've got. Well, the natural second question would be, okay, what if we have a condition on a parent, but we want to get its children? So, for example, find replies to negative comments. Well, maybe we are interested to see how people react to others' negative reaction. So here we have the condition on what we are looking for applies to the second level, to the comments, and the sentiment field should be negative. While what we want to get back are replies. And you see that over here, the structure, we also have this part in square brackets, but well, a little bit counterintuitive. Instead of specifying replies there, we have this syntax as child of. So we still have to specify the parent whose children we are looking for. And then there is this filter query part where we actually specified what type of children documents, well, descendant documents we are looking for. And again, the result, we see that, okay, we asked for replies, here are the replies, no common documents are present because we didn't ask for them. Well, as I mentioned, we are using here actually like this cheat with filter query part, so it's a combination of block join child query with a filter query. And it is a bit counterintuitive and probably not 100% symmetrical to the previous block join parent query. Because block join child query by itself will return all descendants of a document. So if we had a different kind of question, find all descendants of negative comments, then we wouldn't use that filter query and we would get, well, all different descendants, which are level 3, like replies, keywords, and keywords from level 4. And all like in one reply, which is good, but the point is that if you, well, by the kind of preprocessing that we made to the text, I kept this field that indicates to their actual parents, and we can see, like by these IDs, that these descendant documents, they actually correspond to different parents. So right now we have them all mixed. We don't know to which comment they actually correspond, and this is. Well, it might be a feature, might be a bug, but that's how block join child query work. There is no grouping by parent. But what if we want to bring the whole substructure? What if we want to get the comment and then what's down there? Well, Solr has it. it calls, well, the mechanism is called child doc transformer, and it returns the document with all its descendants. So if we ask a question, find all negative comments and return them with all their descendants, then you see over here the structure is different. There we like queried for something and we returned only the descendants, and here we are querying on a comment and we expect like the whole block be there. The example syntax is here, and here's the result. So there is the main query part in green, and then there is this child doc transformer in square brackets that indicates that we want the whole substructure back. So here we see under underscore child documents underscore block, we see the children, but you might notice that there are level 3, level 4, and it's not that I forgot to indent correctly the responses. Unfortunately, the structure is really flat, and why it is so by design. We can get to the documentation and get that child doc transformer returns all descendant documents of which parent document matching your query in a flat list. And this is how it's supposed to be. Well, maybe there will discussion of why it works this way. But right now, what you can do is, if you really need to get the hierarchical structure, there are only workarounds. One of it is, well, because we introduced those path fields, and then that keep all the structure, we could probably reconstruct the document in the post-processing in case when we need the entire subtree. But there is also another parameter to child doc transformer in case we want just a specific level, which is called child filter. So if our query were find all negative comments and return them with all replies to them, which seems like a natural question to ask, then we, in the child doc transformer part, we specify child filter, and we specify the type of the documents we are looking for, which in our case would be reply. And in this case, we see that the response looks very natural. We have the post, and we have replies to those posts, just exactly as our hierarchy is. Well, now that we know that in this child filter part we can actually query child documents, why not like query for something else? For example, what if we want to return all negative comments with all the descendants that mention Trump? Well, yeah, here it is, but again, we see that those descendants, they come from different levels. One is from level 3, another one is from level 4, and yeah, the natural idea would be just to put Boolean condition sort of and return so that they are only replies, but unfortunately it's not possible with child query. Child filter accepts only one condition. So it's mostly been done, I guess, for the cases, for scenarios like this, when we want to specify some type of the documents that we want to return from the subtree. But yeah, like some other querying capabilities are also present in child doc transformer. So as we've seen, querying of nested document structure is pretty much developed in Solr. We can go like up and down the query using different mechanisms: block join parent query, block join child query, and child doc transformer. Some of the functionalities overlap, but also by combination of those functionalities, we can actually do more complex queries like traversing trees. It's not like complete traversing, but still we can do maybe like conditions on siblings going to the parents, or conditions like on grandchild sibling, unless we have we're querying for the same parent. The drawbacks is that, yeah, to get the whole flexibility with this query, and we really need to introduce a lot of pre-processing, like those path fields. They don't just appear there, or like IDs if you want to keep track from which parent all those documents come from. And yeah, in the case of when you have data that changes regularly, it might be a time-consuming effort. But if you have a pretty static data set, then it's a nice solution. So querying is nice part. Yes, search engines, they are done to search for something, but also Solr has this nice analytical capabilities, because Faceting is essentially the analysis that you can do on the data and statistics. And we also might be interested to see how it can be done on those hierarchical documents. So, well, the good news that Solr actually allows Faceting on nested documents, because I know that well, as we just figured out with Anshum, not all people know, because those capabilities are relatively new. There are even two mechanisms but they appeared, one in Solr 5.3 and another one in Solr 5.5. So, well, let's ask similar questions as we did with querying, but now for faceting. What if we want to face it on parents by descendants? So, like which is like not really intuitive. The question would be like, count authors of the posts that received positive comments. So the query part would be comments that are positive, and they're in green, and we want to count the authors of the post, so like the top level documents, and to see like, well, who of them write better, that they receive positive posts. So the result is here. This is a part of the exactly faceting, where we called it most liked authors. And in our tiny data set, we only have 2 posts. There are 2 authors, and both of them received some positive comments, so they both get here. And the count is actually by posts. And here, well, I'm not get too much into the syntax, but you see that in the green part, this is our query, and then there goes this JSON facet, which is JSON facet API with the parent, kind of like this block parent domain, which is also in a block, which specifies the level we want to face it on. And then there is the field by which we are faceting. Here is its author and the type of faceting. Well, so the next step would be, all right, let's go, we went just from bottom up, now let's go top down. So let's find distribution of keywords that appear in comments and replies by the top level posts. It is like, okay, we have all kind of threads, like each post, it starts a thread, and there would be different keywords at different levels, so we just group or take all those keywords and count in how many posts, original posts, well, in how many posts they correspond to. Again, it is possible, it is done with JSON Facet API child domain, which is kind of natural. The output would be, well, this bulky count where you see, so there's top keywords, that's the name of the faceting that we give to it. Then there are keywords, there were Hillary, Trump. In the black font, you see their total counts by just anywhere where they've been seen. And at the counts by post, we know that we only have 2 posts, so the maximum would be a count of 2. Here it is. And so it's all possible. Now, yeah, why I didn't show the query, because it's huge. Here's the query, and it becomes, well, a little bit tricky how to build those queries when you want to face it top down, because you first need to specify one facet for the keywords, and then like another facet inside, which is called counts by posts. This is where you go like counting by posts up there, and what it has there, it actually has this field unique underscore root underscore. If somebody looked at how, well, how Solr generates the schema for nested documents, it adds this field by default. It is unique field that specifies a root document, which is like only top document. So it means that our query is actually, well, more like this chapter should be called faceting on descendants by top level ancestor. And well, the issue is that if we want to find distribution, say by comments, we need actually to find a field that would be specified on the comment level documents that would have unique ID, unique number for each of those. By default, this is not provided. By default, only top level document get this field. So if we like really need to do this, and it's basically, well, it brings us some natural queries like distribution of keywords that appear in comments and replies by comments. We can do so, but we need in the pre-processing step, when we introduce that path field and some IDs, we only need to generate like unique fields for each that would specify all whole branches and like pass them throughout the branch. So here I got this 2 post comments ID, which has unique value for each branch, and I was able to to get the results of this query. So we have like around 3 comments there, and then our comments would be, our counts would be 3. Well, okay, so we've just looked at one mechanism, and as I mentioned, there is block join faceting. So block join faceting is, well, experimental feature. Actually, both of the features are experimental, but this is more experimental because to turn it, the previous one, you can just like load your data if you have enough pre-processing, so you could make it work flexible. It all will be fine, but with this one, you actually need to turn it on explicitly in Solr config, which can be done by copy-pasting the instructions provided on that link. Okay, once you turn it on, now let's just try that most difficult example when we try to find distribution of keywords that appear in comments and replies by comments. So here we see this kind of nice, elegant query, not so bulky as the previous JSON Faceit API. And the syntax, because in the previous section we've looked at the block join queries, we see that here's this block join parent part, where we specify the parent, and then we specify the query, and we say like face it true, and here's our results. The only thing to know that instead of the query request handler, we are using BGQ Faceit request handler, which we just turned on in the Solr config XML. So just to show you that basically they both bring the same results, here are the counts. The formats are a little bit different, but you can see that the counts by comments are the same. The only point is that on the block join faceting, the keywords are sorted in alphabetical order, and it's not because I wanted so, just because it's an experimental feature, it doesn't have a lot of parameters. So like the advantage is that, well, it has nice syntax, it's like very much more similar to the one that we had in block join queries, but right now it doesn't have limit, it doesn't have sorting, whereas JSON Faceit API is way more mature, and it basically, the only point that it needs some pre-processing to do more complex queries, but we have this sort parameter where I specified to sort them by descendant order of counts, so it's all here. All right, so we just looked at the hierarchical faceting capabilities in Solr. We saw that there are actually quite a lot of capabilities. That means that we can traverse the tree up and down and do counts, like all possible statistics that we might like come with in our needs. However, like both of those features are experimental. They are not so but JSON Faceit API is more mature, but yeah, like as I mentioned, JSON Faceit API needs a lot of pre-processing of like your data to make it possible, like to make it 100% flexible. If you use it as is, then you will be able to face it if you want to do this like bottom-up faceting only by root, well, by the top level. Block join Faceit gives like more capabilities out of the box, but it needs to be like turned on in the Solr config, and then it still lacks a lot of parameters for controls like limit and that. So we just provided this summary, and now Anshum will give us a little bit more wrap up on the whole perspective, as he is a Solr committer, why some of the things work as they do, when they will be changed, and so on.
Thank you, Alisa. So yeah, looking at the community roadmap, a lot of the stuff that we just discussed, we did a bunch of that stuff at IBM to solve a few problems, try a few things out, and that stuff works. We need to port it back in a manner that it's more generic, so we still need to get a few things done, and we plan to contribute most of that stuff back. All of the gaps that we said existed, the stuff that needs changing, that stuff is going to come into Solr's, I'd say soon enough. There's a JSON facet rollups that something that would allow you to go ahead and roll up on intermediate levels rather than just being able to go back to the root level, the stuff that Alisa was talking about. There's work already on that. That's the Solr issue number. If you want to go contribute, take a look at it, look at the state of it, you can do that there. There's graph query that's come up. I haven't really explored it a lot. At the conference, I learned a lot about it. But one thing that I know is that it's not distributed. So it works as long as your documents that you're bothered about are co-located on the same shard. Yeah. So I haven't looked at it. I'm also not sure how would I be formulating queries. I'm pretty sure I should be able to do pretty much the same stuff using graph queries. I just haven't tried it. So I'm just saying that's a possibility, and it'd be good to try that part out. There's a lot of work going on. Hierarchical stuff is fairly new. I think there used to be a couple of people who would work on it, but there have been more people now who are now involved with this kind of data sets, and so there's more contribution. But it would be good to have more people contribute to this stuff, especially if you guys have these use cases and there's stuff that you've done internally in-house that you think other people could use. So yeah, that's pretty much about it. Thank you so much. Yeah, you can go.
Yeah, I had a question on, actually it wasn't on the Vanessa stuff, which is really cool, but at one point I saw a tag to Hillary
Yeah.
where the actual text that said Clinton something and then she said this, right? So there's no actual term Hillary in there, and you had this effect, you're like not only Hillary by the gender,
Yeah.
but also not to wouldn't get built.
So not for this data set, but for most of the stuff that we did internally, we used the Watson Alchemy APIs to get way more richer extraction of information from the original data that we had. Yes. Yeah. Are you saying spatial? So yeah, I mean, so.
You showed all our, you have to explicitly mention the path that we have.
So the thing that we highlighted in this talk was about the importance of paths themselves and how that you could use that to kind of build a relationship between documents. Solr certainly allows you to mix and match a bunch of different query parsers all as part of the same query. So you'll be able to do that as well. Yeah. Yeah. Okay, so the question is about do we have any numbers about performance if we have a huge number of documents. We did not benchmark this. We haven't gotten to that point. But now that we've seen this work, I'd probably want to get that and get at least some numbers out. At this point, what we've tried is, in terms of depth of document at least, we've tried it out to I've tried it out to about 7 levels of hierarchy with enough data that the Alchemy API gives. Share with you more about the data set. We did it on the Enron email data set that's publicly available. So we used that data, used the NLP APIs, extracted a ton of information that got us enough levels of nesting. And we didn't run into any issues there. But again, this was all local testing, stuff that we were working on. It wasn't production level stuff by any standard. So, I mean, in terms of testing it out. Yeah.
No, but anyway, there was some comparison because we were in comparison to like the other product.
Yeah.
And just by running the queries on the same data set that was around like 1,000 documents and with all the nested documents, Solr runs faster. Well, because they print out how fast the query was, right? So, I mean, it's not like gigabytes of data, but like if you compare to the competitor.
Yeah, I
Solr
mean, she's just saying, we compared it against Elasticsearch in terms of the offerings and how it compared. The numbers, at least that Alisa found, were better for Solr, for our data set. Yeah. Okay, we're going to be around for the rest of the day if you guys need anything more.